Welcome back. Let me explain the idea of NQ and DQ operation on this circular queue. Okay, we have initialized the rear and the front marker at the end of the array. You can see that both the rear and front is size -1 and the size of the array is 5. That means both the rear and front at the very beginning of our program is going to be at index 4. So this is the underflow condition, right? Because the initial condition is our underflow condition as the array is empty at the very beginning when we start. And we put the rear and front at the same place. Now if that happens again, if the rear and front comes at the same index again, then we'll consider that the array is empty. This can be understood in a different angle as well. Say at the very beginning you are calling the DQ operation. Now what you are going to get from DQ? Obviously DQ is going to tell you that the queue is empty because at the very beginning there is nothing in the queue, right? So at the very beginning, what's the position of the rear and front? They are both at same place. So that's the underflow condition. So we'll be using this for checking our underflow. If the rear and front they are at same place, then the queue is empty or queue is underflow. Now how we are going to check the overflow, that I'm going to tell you soon. Just keep watching because understanding the condition for overflow a bit complicated one, and you'll only understand if I move ahead and tell you how we are going to insert the elements at the rear index. So let's go ahead. The insertion is going to move the rear to the next element. That's the first step for inserting a new element into this circular queue. So we'll be moving the rear using this statement as I told you in the last tutorial. So this is the statement that's going to move the rear to the next element. So now the rear is actually 4, so 4 plus 1 is 5, and 5 mod 5, the size of array is 5, don't forget that. So 5 mod 5 is 0, so the value of rear is going to be 0 if we perform this operation, right? So in order to insert, first thing we need to move the rear to the next index, and we'll be doing that using this operation. So the value of rear now goes to 0 instead of 4, it will be 0 now. And we are here and we'll be placing our new value that we intend to insert at the 0th index. So the algorithm for the NQ is straightforward. First of all, we need to check if the array is overflow or not. If not overflow, then we need to move forward the rear using this statement. That will move the rear in circular way. And then we need to place the new value that we intend to insert into the element where the rear is right now. So we are placing that 5 here at 0th index because rear is right now 0. Now if you want to insert another element, then again we'll be doing the same thing. We'll check if the overflow is there or not. It's not overflow. I'll be telling you how to check the overflow soon. Don't worry about that. Let's keep going. So we'll be increasing the rear using this statement, rear equals rear plus 1% size. In this case, the value of rear is 0, so 0 plus 1 is 1, and 1 mod size is actually going to yield 1. So rear is going to be moved to this index 1. Now we are going to place the new value here at index 1. So say our new value is 10, so 10 will be placed here. So now if we want to do the NQ operation couple of times more, then obviously we are going to do the same thing. We'll be increasing the rear to the next element. So rear will come here and we'll push the value here at index 2. Now let's do the thing one more time. We'll be incrementing the rear to the next element. So rear goes at index 3. Now currently it's 2. 2 plus 1 is 3. 3 mod 5 is 3, right? So it goes here. Say the new value that we want to insert is 20. So 20 is going to be inserted at index 3. Now, can you perform one more insertion there? If you call the NQ operation, and if the NQ actually moves the rear to this index 4 now, and you place a new value here, that's not going to happen. Okay, I'm just telling you, if you allow, then what's going to happen? Okay, so if you allow the rear to move to the index 4, where currently the front is, we have not moved the front yet, right? And you place the new value there at index 4, then you are doing something wrong. Now, if you allow that, then what will happen if you call the DQ operation? DQ operation will check the underflow using this condition, right? Rear and front are at same place or not? Yes, they are. So in that case, what will happen is the DQ operation is going to tell you that queue is empty, right? So you cannot allow the rear to go ahead if the next element is the front element, right? If the front is on the next element. So if you allow to do that, then it will satisfy the underflow condition, even though the array is full, but your dequeue operation is going to tell you that the queue is underflow. So the overflow condition actually now can be derived. We cannot allow the insertion or enqueue operation to insert a new element there if the next element to the rear is a front. That means if the rear plus 1% size is front, you see that rear is here, rear plus 1 mod size is 4, and the next element where the front is right now. So you cannot allow the enqueue operation in this situation. So here we go. The condition for overflow is if rear plus 1 mod size that's equals with the front, then it's overflow. Now we need to check it circularly because the next element to the rear could be the 0th element when the rear is currently at the last element. Now let me explain that. We can just now try to perform the dequeue operation and see how the deletion takes place there in this queue, and then we'll move ahead and do some insertion to show you how this circular checking actually performs the thing there. Okay, let's now delete or call the dequeue operation and do the dequeue there. Okay, for dequeue, we'll be moving the front in the same way. That means using the same statement, f equals f plus 1% size, right? Okay, here it is. So this is the same statement, and front will be moving circularly like rear. So right now front is 4, so 4 plus 1 is 5, and 5 mod 5 is going to yield 0. So the front will be moved to the 0th index. That's the firstly inserted value, right? So front is right now here at 0th index, and it will be deleting this. We'll be picking up this value from the 0th index and we'll be returning this to the caller. So now if you like to insert or perform the enqueue operation, then you can do that. You see that the front is not there at index 4. It is moved to the next index that is 0. So the next element to the rear is now vacant. So we can perform the enqueue operation right now by doing this operation. So if the enqueue is called, rear plus 1 mod size is that front. Rear is right now 3 plus 1 mod 5 is 4, and the front is at 0. So they mismatch. So we can just move the rear to the next element, that is 4, and can place the value there. You can perform the insert operation or enqueue operation. Now can you do it once more? No, you cannot. Now you can see that the rear plus 1% size, that's 0, right? Rear is 4 plus 1 mod size, that is 5, is 0, and the front is at 0th index. Now when we described this circular queue, we understood that both the rear and front moves circularly over the array. That means the next element to the last element is the 0th element, right? So the next element to the rear is right now front, and we cannot insert. If we allow the insertion, then both the rear and front comes at the same point, and then it will satisfy the underflow condition. So if we call the dequeue, in that case, then the dequeue is going to tell us that it's underflow. We cannot allow one more element to be inserted there into the queue. So the queue is right now at overflow state. So it's performing the first in first out order, and it's utilizing the vacant elements at the bottom of the array, as you can see. Unlike the previous case where we were unable to utilize the vacant elements at the bottom of the array, here we are moving the rear and front circularly over the array, and that's doing the trick. So in the next tutorial, what I'm going to do, I'm formally going to write these algorithms, the enqueue and the dequeue algorithms for this circular queue. Okay, keep in touch.